Question 9 reads, the system of equations above is graphed in the xy plane. Which of the following is the y-coordinate of an intersection xy of the graphs of the two equations? They're asking for the y-coordinate of the intersections. Well, if this is the non-calculator test, and well, if it was on the calculator part, we could put it in a graphing calculator and easily solve this question. But just for a demonstration, this is what, or somewhat how the scenario looks like. We have a parabola, the first equation, right, which is a quadratic, and then we have a line cutting through, and then there are two intersection points. Obviously, we don't have a graphing calculator, and we have to find another way. And the way actually is quite simple. We just replace the y here, just plug in this stuff for y, right? Because this equals x squared minus 6x plus 11 equals y. And so I can just plug all that into this second equation. And so if I do that, it's going to be something like x equals, now I'm going to replace the y with x squared minus 6x, well, I'll do a different color so it makes more sense, x squared minus 6x plus 11 plus 1. Okay, so now we can solve it like a normal quadratic, how you would solve to find the solutions of a quadratic. So the way I like to do it is, or the general way is that you make one side equated to 0, right? And so the way I can do that is taking away x from both sides. And so it's going to be 0 equals x squared minus x, right? I'm taking x from both sides, right? And so it becomes minus 7x plus 11 plus 1 is 12. Okay, and so now we can either use the sum and product method, the quadratic formula, to solve, find the solutions of x, right? And so what I'm going to do is I'm actually going to use sum and product. And sum and product basically means, if you're unfamiliar, it means that I have a sum, which is the coefficient of x, which is minus 7, and a product, which is the constant term, 12. And I'm basically finding two numbers that when they add up, they should equal minus 7. And when they multiply with each other, they should give 12. And if you think about it for a bit, you're going to get, the two numbers are going to be minus 3 and minus 4. And so if I rewrite this quadratic, it becomes 0 equals x minus 3, x minus 4. Okay? And if I solve for the x's, these guys have to be equated to 0 each, right? And so it's going to be x minus 3 equals 0. And so x equals 3. And x minus 4 equals 0. X equals 4. Okay, so these are, obviously this is not to scale or anywhere correct, but if you think about it, this is going to be 3 comma y, 4 comma y, something like that. Okay, obviously this is a inaccurate drawing, but that's what we have so far, the x coordinate. And this is where a lot of students and people who solve this question can fall into this trap, which is it asks for the y coordinate. So do not put 4 as one and select D, because they're asking for the y coordinate. And the way we can solve for the y coordinate is quite easy. Take both of these x's and plug it into the second equation, okay? Or the first, but the second is a bit easier to work out. So if I take 3, it's going to be 3 equals y plus 1. So y equals minus 1 on both sides. Y is going to be equal to 2. That's one of the y coordinates, right? So here it's going to be 2, right? And if I do 4, right? X equals 4. 4 equals y plus 1. And so y minus 1 again, y equals 3, okay? And so 3 would have been a y coordinate as well. Obviously, we do not see 3 in any of the answer choices, so we can just leave it. But we do see 2, and so C is our answer.